So, TrustSec, group-based policies, adaptive policy, micro-segmentation, security groups, whatever you call this technology, it's come a long way in the last few years. So I'm here to talk about the technology, but more importantly, some new innovations in this area. So one thing, or at least one thing I want to take away is that this is about security agility using TrustSec and group-based policies. So my name is Jonathan Eves, and I'm a technical marketing engineer at Cisco. Hopefully you've all got the WebEx app. Very important. You'll have a PDF of this on there later. But also, you can ask questions on there, and this is going to be open for 2 weeks. So if you don't ask today, then you have 2 weeks, and I'll get back to you as soon as I can. But more importantly as well, it's that there's a survey on there, so please fill out the survey after the session. So I'm going to go through an introduction, and the 3 pillars of the technology: classification, propagation, and enforcement, and then something that's just come out, something called common policy. So I'll talk about what that is, and maybe more importantly, what it isn't. So an introduction then. Identifying use cases, so simplicity. Simple ways to protect things on the network, simple ways for network access, but also to provide important things like segmentation and least privilege. Another thing is to represent threat state. So if something is threatening, how do you represent that and deal with it appropriately on the network? But also vulnerable devices. How do you label them and protect them from the rest of the network, or maybe more importantly, how to protect the rest of the network from those devices if they get compromised. And then adds, moves, and changes. So you can set up the technology. Once it's set up, because of the dynamic nature, it really saves in the operational adds, moves, and changes of the network. So why does it matter? I'm sure you can tell me lots of reasons, all sorts of attacks that we see in the news, phishing attacks, cyber attacks, and all sorts of things. So it's very important for these topics of segmentation and using security like least privilege. So let's talk about the policy challenge then. Traditionally, let's say a person is working at a desk and they're on a VLAN, so they get an IP address from a subnet. And if you're basing your security policy on those constructs, then that's a local entity, and you build IP access control lists from the local entity of the IP address. Now, if that person moves to another desk, perhaps on the same floor, typically they may be on the same VLAN, and maybe even the same IP, so your security policy wouldn't necessarily have to change. But what if the person moves to another floor in the building? They'd quite likely be on a different VLAN, different subnet, they'll have a different IP, so your security policy would need to change, different IP address. And might move to a different building, again, different VLAN, different subnet, a different IP, so your security policy might typically have to change. And lots of us have flown this week. Again, we fly somewhere else, different building, different IP address, different security policy. So the policy challenge is, your policy is tied to infrastructure components, such as the IP address. And also the business intent. Very, very confusing with a whole list of IP access control lists. I know companies spend a long time adding these entries, and particularly a reduced amount of time removing the ones that aren't used anymore. So these tend to grow exponentially. And very confusing to understand. So let's go back one. Yeah. So let's talk about how do we simplify the security policy. So we've got these individual entities, just as an example. We've got some doctors, and it doesn't really matter where they are. It's around the globe somewhere, and they're doctors. Now, assuming we want to deal with these doctors in a similar security way, why don't we group them together and call that group something which is meaningful, something like doctors, and then try and deal with that as a group basis instead of dealing with them as individual entities. So there's something else here called the patient record servers or services. Instead of dealing with them individually, why don't we group them together because they have a similar security need? And let's give it a meaningful name, like patient records. And this is our security policy. It's very simple. It's from the doctor's group to the patient records group. In this case, we might want to permit that traffic. As another example, some health monitor systems. Let's group them together, give it a meaningful name, something like health monitors. And now, I perhaps want to block traffic from health monitors to the patient records just in case the health monitors get compromised. But we certainly want the doctor's group to gain access to the health monitors. But maybe we want to restrict what we allow, maybe restrict the non-secure protocols but allow the secure ones. So this is our security policy, and this is how we simplify it, as opposed to tying the policy to the likes of local entities like the IP address. But most importantly, things move, okay? Services move typically these days. Users definitely move. But if they move, there's no reason why they can't be assigned into the same group. So your policy doesn't have to change. This is the main reason for this technology, right? Things can move everywhere. They could be in the same group, but your policy doesn't change. It's still doctors to health monitors and so on. And the business intent is much clearer. Even down on the CLI level, you could have the policy on the switch or the router or the device. Default policy is a deny in this case. It's very clear to understand. It also based your security policy on these groups. So from scanners to storage, permit the traffic. Again, very easy to understand. And employee to directory systems. Here we're permitting certain protocols. So it's very easy to understand, but we don't sit on the CLI much these days, so even in the UI, we have an easy to understand matrix. Down the left is the source group, and across the top is the destination group. And the intersection is what we actually want to do in terms of denying or permitting. And very easy to understand, as we have this UI in Catalyst Center and obviously in Identity Services Engine. So I had a customer come to me at Cisco Live Amsterdam, sat down and said, I'm starting to use SGTs, and okay, I'm assigning SGTs, and I've got this policy, but I don't quite get it. And I said, well, what about the mobility piece? What if the user moves? Your policy doesn't have to change. And it's quite fun because his eyes sort of widened and he had this light bulb moment, and he sort of realized, and he was excited to get back home and try things out again. So hopefully you've had this light bulb moment in the past. If not, maybe you will during this session. And again, I want to say this is about security agility using TrustSec and group-based policies. So that was the introduction. Let's go on to classification. By classification, we mean putting things into groups. So what do we put into groups? There are lots of things you can put into groups. These are just some very simple examples. Contractors might be guests. We might have building management systems, manufacturing. I've got examples of cranes or robots or whatever it might be. More mundane things, printers, IP phones, whatever it might be, and servers or services, putting things into groups. Now, you don't necessarily have to put everything into groups. What's nice is there's such a thing as an unknown entity, and you can build policies with the unknown. So yeah, you can, best practice is to start small, and you could just start in a very, very small part of the network and just classify those things to test things out. So that's putting things into groups. And how do we put things into groups? Well, we use an SGT, a security group tag, and this is mostly dynamically assigned by Identity Services Engine. So when things come onto the network, they authenticate with ICE, Identity Services Engine, and we authorize those entities into groups. So we assign an SGT or a security group tag, typically dynamically from ICE. And on the left here, we have dynamic methods. This is using ICE through radius authentication and authorization to assign the SGT. But let's say you have some devices on the network, servers or what have you, that are never going to authenticate with ICE. How do we put those things into groups? Well, we use static methods, okay? So you might put the IP address of a server into a group or the subnet. We can use a layer 3 interface putting prefixes into groups. We can use a VLAN, what we call a VLAN to SGT, which actually learns the IP addresses on the VLAN and puts them into groups. So we have some static methods to put things into groups as well. So this is how typically we put things into groups. But ideally, we want to use ICE to dynamically assign those SGTs or those groups. And some people, get started, try and boil the ocean, do everything, classify everything, and enforce everywhere. Well, you don't have to do that. It's a journey. You can start small, as I said before, but you can start just with visibility, just assigning SGTs and looking at flows on the network based on the groups. So you don't even have to enforce, right, initially. So how would that work? This is an example. We've got a doctor here connecting to this left-hand switch, and we're authenticating with ICE, and ICE through authorization is assigning an SGT, in this case, the doctor's SGT. The right-hand switch, we've got a scanner, connects, authenticates with ICE. ICE assigns the SGT, in this case, the scanner's SGT. We don't need policy initially because we now have visibility. These things are assigned into groups. And if you're already using ICE and with MAB or .1x, maybe assigning an dynamic ACL or dynamic VLAN, then assigning an SGT is just one more attribute. That's all you have to assign to classify things into groups. But this is an example using NetFlow to Cisco Secure Network Analytics. Cisco's Secure Network Analytics will see the SGT. It'll see it from ICE using a sharing mechanism on ICE, if you're familiar with PX Grid. And so you can see your flows based on groups in Cisco Secure Network Analytics. Similarly, in Catalyst Center, we have the group-based policy analytics application. It's the Sankey chart, from source group to destination group. Again, visibility, group-to-group traffic. We're not enforcing anything here. This is just assigning SGTs and looking at visibility. And on top of that, of course, we do share this information with other platforms. There's a new integration with our ACI controller APIC, which I'm going to talk about later in common policy. We share this information with our firewall, Cisco Secure Firewall, and also we share this information over what's called Security Group Tag Exchange Protocol, or SXP. Sharing this binding, we bind this SGT assignment to the learned IP address. We have this IP to SGT binding or mapping, and we share that over SXP to our network devices, routers and switches and so on. So that's visibility. Something I wanted to talk about, default route SGT. Not that well known, but it could be very, very handy. Because lots of people say, well, I've got an internet gateway, I've got traffic coming in, how do I classify that traffic? Normally you'd be, as I said, putting things like printers and building management systems into groups. So what about traffic from the internet? Well, this is a very handy feature for that, the default route SGT. Now, one thing is that you need a default route on your device, your Cat9K, for example. But we can use that to classify traffic inbound. So traffic coming inbound, we can classify it into a group, forward it on so that traffic in that group is from and to, or at least from the internet. But we can enforce outbound as well. So if you've got traffic going to the internet and you wanted to permit or deny traffic to the internet, then you can use this feature. It's very easy to configure. It is only CLI, so it's not supported on Catalyst Center or Identity Services Engine, but you configure it on CLI, but you map it it's a specific IP address, 0.0.0.0/0, and you map it to an SGT, and you see it there on the CLI. Very useful feature, particularly for classifying and enforcing internet traffic. Okay. So, again, I had a customer come up to me in Cisco Live earlier this year. Said, I got a problem. I've got Identity Services Engine. We've got a limited number of authorization rules. I'm using a large number of them, and I'm running out of space in authorization rules. And I want to assign quite a few more SGTs, so I find it impossible to do that. I went, well, we've got a solution for you. You can do a lookup for the SGT in the likes of Active Directory. So this is an example of me hijacking an attribute in Active Directory. It's the You see the alt security identities attribute, but you can create your own if you wanted to. So, and the value of that is what ICE would send down in an authorization to assign the endpoint or the user into a group. So what we do in Identity Services Engine is we retrieve this attribute and say, right, we want to use this attribute in our policies. And then we add an authorization profile to say, when the authorization goes down, I want to add this extra radius AV pair, and this is the attribute I want to send down, or at least the value for that attribute. So this top right record is for Dr. Indiana Bones. So doctor comes into the hospital in the morning, authenticates with ICE. ICE, through authorization, knows the identity, so sends down that new AV pair in the authorization and assigns into a group. So it's an AD lookup for the SGT. Really, really saves on authorization rules. And the customer said, brilliant. Love that. That's going to save me some rules, but I have endpoints which don't have, entities in Active Directory, so I've still got a problem. And I said, oh, well, we have a solution for that. So this is a fairly new innovation called PXGrid Direct. And this is how it works. So we can retrieve records and attributes from an external server. So this is just an example of CMDB with ServiceNow. We make a request to the server, and we download these records and attributes. It comes down in a JSON format with all these records and attributes. So this is just a very rough example of something I put in the lab. So owner, myself, owned by J. Eves, class name, updated, location, all sorts of attributes. But one interesting one is that you can have still in the middle there, the group tag. So again, that's a value that ICE can send down to use to authorize things into groups. And we can say, which ones of these attributes do we want to use in our policies? So we select the policies, select the attributes that we want to use, and then build our policies. So what's nice about our authorization rules is that in our authorization we have conditions. So in the conditions you can use some of these attributes. And also in the results of authorization, you can use these attributes in the result as well. So you can use location, owner, what have you, as conditions. And then the result is to assign the SGT. So the customer was fantastic and was happy and went away and can save on a lot of his authorization rules using this feature. So again, this is about security agility using TrustSec and group-based policies. So let's have a look at a demo of PXGrid Direct. So this is Identity Services Engine. And we go to Administration and PXGrid Direct connectors. I've already got one added, so let's just have a look at the configuration. So we'll select it, have a look at the credentials initially. If we're going to connect into this server. We've got an update timer, and we've got the attributes. So these are the attributes that we've received down, but we're selecting the ones that we want to use in our policies. So if there's location, department, whatever it might be, but what's important is the SGT. We want to assign that as a result. But of the other ones we can use as conditions in our rules. We save these to be able to use them in our policies. So I've selected some of them. And the identifiers is what do we use as a link into the record in the database. So we can sync now, even though there's a timer, we can sync it now. So we're syncing it. And we can look at these records in our context visibility. So in here on the right-hand side, these are all the records that we've downloaded, and we can select them and look at all the attributes per record. And this entry at the bottom here has a lot of entries, again, location, name, whatever it might be. And you see some examples there. But we have an attribute here which we can assign the group tag, the SGT. So we need our authorization profile. And at the bottom, we say we want to send down this extra radius AV pair, and we want to send down the value of this attribute. So then all we need to do is build our authorization rule. And of course, in authorization, it's the conditions, what conditions have to match. These are examples of assigned to contains example.org, and the department is marketing. If that's true, then I want to assign this new authorization profile, which sends down this SGT. So it's a great feature, particularly to save on authorization rules. Okay, so that was classification, putting things into groups. So let's move on to propagation, and let's cover what that actually means. So where does enforcement occur here? Right, this is standard Ethernet from left to right. Let's talk about a flow from left to right, from the doctor to the scanner. And let's say all these 5 switches, say, are all configured for TrustSec and group-based policies. So they're totally configured. They're all configured to enforce, okay? The left-hand device has seen the doctor connect. We've authenticated with ICE. ICE has assigned an SGT. It's all classified, and it's also downloaded a policy. And so is the scanner. Scanner's connected, authenticated with ICE. We've assigned an SGT. It's downloaded policy. So everything's in place. So where does enforcement occur in this path? Any takers? At egress? At egress? Okay. So let's talk about that. So where does enforcement occur? So enforcement occurs at the first platform, the traffic path, in the traffic path, which has all of the following. Okay? The source IP to SGT binding. Now we know the left-hand switch has the source because it's connected, we've assigned the SGT, so it has the binding of the IP, learned IP, to the group in that left-hand switch. A switch also needs to know the destination IP to SGT binding, in this case the scanner. The platform and the VLAN has to have enforcement enabled. I said that's enabled. And a policy needs to be downloaded from ICE. Now, a policy is downloaded. So where does enforcement occur? Well, it doesn't occur anywhere here. Nowhere in this path does it enforce. So why doesn't it? It's because the left-hand switch here knows the source binding, but it doesn't know the destination binding. No one's told it. The right-hand switch knows the destination binding, but doesn't know the source. No one's told it. So there'll be no enforcement in this path. Okay? So this is where propagation comes in. And typically, we propagate the source SGT binding. So one of the ways we do that is with inline tagging. I'm sure a lot of you have heard of that. It uses the Cisco metadata field in the layer 2 frame. So for every packet from the doctor towards the scanner, we put the source SGT in the layer 2 frame. It's propagated from left to right. The right-hand switch now knows the source binding. It sees it in the packet coming in. It's actually in the frame. It sees the SGT. It knows the source IP. So it sort of does an internal lookup. I know the source. I know the destination because the scanner's authenticated on it. Okay. I have everything configured I need. I have a policy, so I enforce at egress. So a lot of you are right. It's just that the right-hand switch didn't know the source binding, so it wouldn't have enforced previously. But inline tagging is needed to carry the source IP to SGT binding. Now, there are lots of other things you can do here. We propagate this IP to SGT binding through PXGrid, also through security group tag exchange protocol. So in this case, SGT takes that destination IP to SGT binding, and you can send it where you like in the network. In this case, it's sending it to the middle switch. Now the middle switch knows the source IP to SGT binding when traffic comes in. It knows the destination because it's learned it for SXP. It's configured to enforce. It has a policy downloaded. When it learns the SXP mapping, it downloads the necessary policy. And so in this case, we enforce in the middle switch. Again, propagation, inline tagging, SXP, PXGrid. These are propagation mechanisms. Identity Services Engine also supports SXP. We could send bindings or the destination binding from ICE down to this second switch. And now the second switch knows the source binding because it's learned it through inline. It knows the destination binding. It's learned that through SXP. It's configured to enforce. It has a policy, so we enforce on the second switch. Okay, so this is propagation. And as I talked about, there are several methods of propagation. In this case, we talked about inline tagging. And lots of questions come up. Well, I've got a WAN, wide area network. How do I deal with that? Well, with Cisco devices, at least, we support GRE, IPsec, DMVPN, and GitVPN to get the SGT across a wide area network. So this will be inline tagged in the data plane. Every packet from the doctor towards the scanner, it'll hit the destination switch and will enforce at egress. By the way, I loved your answers about egress. Yes, we typically want to enforce at egress enforcement. ICE supports SXP. We've already covered that. We can send the bindings down to devices in the network. And our network devices support SXP. We covered that before. But PX Grid, we send this IP to SGT binding information through PX Grid. Cisco Secure Firewall is a consumer of that. You can build policies using groups, really simplifying your rules. We propagate over PX Grid to SD-WAN. So the old name of vSmart, we'll use that, send that down through OMP. We can enforce on FC edges and SD-WAN using groups, as I say, OMP. And of course, our flagship software-defined access, propagation is inherent in the technology there, uses VXLAN. The SGT is put in VXLAN. So again, enforcing the egress, traffic flows from the person on the left to the person on the right on the fabric. It carries the source SGT over VXLAN and enforces that egress. So the propagation method there is VXLAN. One question.
Why do you enforce on egress when you might want to just drop the traffic? Why transmit it all the way across the network?
Yeah. Great question. We get that quite a lot. So the question is, why enforce at egress? Because typically you may be used to enforcing more on ingress. Well, the first thing is, this technology is an overlay technology. You can use IP access list as well if you wanted to. So if that was, easier to do some sort of ingress enforcement, you can use IP ACLs. But also, the reason why you enforce at egress, if you think about the boxes on the egress of the network, you have endpoints connecting to those switches, and they're being assigned SGTs. Now, as soon as an SGT is assigned to that box, it downloads policy to protect that SGT. So let's say there are 10 different SGTs per box. It'll download policies just to protect them. The nearer you go to the source, there's more destinations and more SGTs to protect, the more policies it has to download. So the reason is for scale. If you think about all the boxes at egress, they only need to download policy to protect the SGTs it knows about, which is much less than as you get closer to the source. And if you think about the source itself, if you want to enforce there on a group basis, you'd have to download policy for every other remote SGT. So that's why we enforce at egress, it's for scale. Okay, it's a great question, thank you. Yep. Okay, question?
A lot of this enforcement, as you mentioned, can happen in a couple of different spots depending on the propagation.
Yeah.
And a lot of this enforcement, because we're talking about lower down, obviously close to the access layer, is stateless. We're talking about switches. We don't generally log stateless rules because they're too noisy. It's not viable. How do we troubleshoot a block and we don't know where it's coming from?
Yeah.
Do these methods of blocking, these methods of control have their own log line that isn't as noisy as your standard stateless log?
Yeah. Okay, great question again, thank you. So the question was about troubleshooting, really, with drops on the network. If you're denying, how do you troubleshoot or at least monitor drops in the network? Because we have several enforcement points, and enforcement occurs, you configure it, you can configure enforcement where you like, depending the platform supports it, of course. So yeah, great question. And we do have counters on the switches. You don't really want to be logging into 1,000 switches and looking at the CLIs. But those counters are exported via telemetry to Catalyst Center to begin with. So in the policy table in Catalyst Center, there's a matrix. If you click the top right-hand corner, there's a table. You go into the table, and it shows drops exported from the switches in there. It's not as granular as I would like it because it shows it per policy, not per access device. So it would be nice to show per access device, but it's a resource thing. Also, since inception, we've had syslog, which I'm sure you're aware of. So when counters are hit, once, and also then if it's busy, it counts 100 and then sends a syslog. And of course, you need a receiver for that. And of course, we've got a great integration now with Splunk. So Splunk might be a good receiver of those. And syslog is busy, as you say, CPU intensive in cases. But we have a new innovation of exporting these in NetFlow as well, which I will cover shortly. So thanks very much for your question. Hi, Peter.
Sorry, just one more. On your previous slide, as far as transport's going, something we could probably now add to that as far as the catalyst and the malarkey SD-WAN.
Okay, so yeah, thanks. The statement was about other technologies we have that carry the SGT. So yeah, there's a few things that I didn't have in here, so thanks very much for that, Peter. Okay, thanks a lot for the questions. Order of precedence. What if you've got inline tagging coming into a box? IP 1111 mapped to SGT10. But then what if you've got a static entry in that switch, assigning 111 to SGT20? And what if you've got an SXP entry, 1111 mapping to SGT30? Which one takes precedence? Well, inline tagging is the highest, and I can tell you VLAN to SGT is the lowest. But you can look at this later in the interest of time. This was just for reference. SXP, for the last few years, we've been using SXP version 4, the latest version. But we had a bit of a challenge there, and SD-Access sort of brought this to the front. This is just an example, but SD-Access, you have virtual networks, which is akin to VRFs on the devices. And you might want to send IP to SGT binding to a border, for example. But you may have 10 VRFs. But SXP v4, you need to terminate a connection on each VRF. So you would need 10 SXP connections. So that's what this is showing, an example with three SXP connections terminating. Now, 1791, we came out with SXP version 5. And what this does really is it concatenates that. It allows you to have one SXP connection, but we carry the VRF information in the packets, in the SXP technology. So we don't just carry the IP and the SGT, we carry the VRF as well. In fact, we carry the VLAN additionally to that as well. So as an example, we connect from a Catalyst device on the left to an SD-Access border. Again, it's just an example. And maybe we've got 2 VRFs there, or virtual networks. We just need one SXP connection to carry that VRF, all those mappings. And the right-hand device, the border here, will put those bindings back into the VRFs because it receives that information. So it is CLI configuration. The left-hand box here, the reflector in this case, you have this export list, and we say we want to export both these VRFs, so the building management and building security. And then the export input group just references that and configures the peer, because you could have multiples of these. The receiver side, the border, we have this import list, and this is a special config. We just put VRF, and that means the VRF information that comes over the wire will put that information back in the same VRF. So you just need one configuration there. And again, the export input group just references that and configures the peer. So this makes a big difference in a software-defined access network. If you have several VNs, you now only need one SXP connection instead of multiple. Cisco Identity Services Engine doesn't support SXP v5 just yet. It's coming out very soon. So that's why this example, the source is a Cat9K, but ICE is coming out with this very shortly. Of course, we have multiple devices these days, from Meraki devices to the Cisco Cat9Ks. We're integrated, it's Cisco, it's one Cisco these days. And the technology interworks. The technology is the same, okay? Like I said right at the beginning, adaptive policy, but it's the same thing. Inline tagging, we've got inline tagging in red. We're going from the MRs to the switches through the Cat9K. In this case, the Cat9K is dashboard managed. It's inline tagging. You know, we have a device not dashboard managed, 9500 in this case. It's inline tagging. It's the same. Doesn't matter. All interworks. One interesting thing, though, is that from a policy point of view, the 9500 here would download policy from ICE. But of course, the Meraki devices will download policy from dashboard. So that's an interesting one. But in ICE 3.2 patch 1, we had a policy sync function. So when you have your SGTs, your policies, your SGACLs in ICE, you can sync that to dashboard so that you have a synchronized story. Okay? Remember, security, agility, using TrustSec and group-based policies. So at some point, we may want to enforce traffic. By enforcement, we may want to permit or deny. So let's talk about the whole story. I talked a bit about this. But let's use the same example. We've got doctors and scanners, but remember that the policy engine is identity services engine. No matter where you're orchestrating the policy from, of course, we could have Catalyst Center, a great orchestrator for network and pushing things into ICE like the policy. So your SGTs, your policies, your SJCLs, or called contracts in Catalyst Center, can be pushed into ICE. ICE is your operational engine. We have a doctor connect to the left-hand switch. We authenticate with ICE. Through authorization, we assign the SGT, the doctor's SGT, classifying that. We talked about that before. As soon as that left-hand switch knows it has that doctor's SGT to protect, it'll go to ICE and say, have you got a policy for me to protect this SGT? If it does, it'll download it. What does it download? Only the policy that's needed to protect that SGT, so it happens to be this column. It just goes back to the question of scale, egress or ingress. Only downloads what's needed. Scanner connects, authenticates with ICE, authorizes with an SGT, typically the scanner's SGT in this case. As soon as that switch knows it's got that to protect, it will go to ICE and say, have you got a policy for me to download? Which does it download? Well, it's the policy to protect that scanner's SGT, so it's that column in the matrix. So that's classifying things into groups. There's one question.
In a large-scale environment,
Yeah.
we have a lot of endpoints logging in at a point in time, let's say 10,000 endpoints logging within a container window. How are the limits dealt with from ICE to the switches and traffic that is before those policies?
Okay, so the question is more about throughput. If you have a lot of endpoints come into the network at the same time, and they're all authenticating, what's the throughput? Well, one answer I would have is that we have a great performance and scale document for Identity Services Engine. You're probably all familiar with that. If not, then ask the question on the app, and we can get back to you on that. But that will have all throughput measurements. But ICE is a very scalable platform. You can have multiple policy services nodes, up to 50 around the globe. And I must admit, I've never really had that question before in my whole time of dealing with this technology. But I've never had any customer say that it's been a problem. But yeah, in terms of scale, just make sure you're within the limits of the system, and you should be good to go. Thanks for the question. So yeah, once this is set up, we've got SGTs assigned, we've got the policy downloaded, and it's in place, right? That's all control plane stuff. And then we get to data plane. The user wants to send traffic to the scanner in this case. And this is where propagation comes in. The source IP to SGT binding is sent to the right-hand side. It's just in the packet. It's in the layer 2 frame because it's inline tagging. The right-hand switch knows then the source IP and what group it's assigned to. It knows the destination. It's been configured to enforce. It's downloaded this policy, so we enforce at egress again. Okay, this is all working together. A great use case. Lots of customers ask about this. How do we reduce lateral movement, malware propagation, particularly if we've got lots of things in the same group? So as an example, we've got this user connecting to the network. The customer hasn't yet been more granular, but it's going to assign an SGT to all employees because they have all the same security need. Another user comes in, connects, and they get assigned the employee's SGT as well. So they're both in the employee's SGT. Because we've talked about enforcing from one group to another right now. But if you look at the policy matrix down the diagonal, it's from and to the same SGT. So the hand at the bottom, employees across there, and then 2 employees at the top. We can build a policy for this, and it works exactly the same way. So you may want to deny sort of well-known ports that are used for malware propagation. Or what I typically like to do is only allow the protocols that you know should be allowed between these users. So some sort of collaboration protocols, for example. But deny everything else, have an explicit deny at the bottom of the SGACL. But either way, even if these employees are on the same switch, 2 ports next to each other, same VLAN, same subnet, this will enforce. So you could have 1,000 employees around your network, and they'd all be assigned this policy. So it's a great use case for limiting malware propagation. Packless. Now, Technical Assistance Center, TAC, have a number of calls per week on PAC. Now, what is the PAC? It's a protected access credential. It's part of Eat Fast. It's the way we set up some security mechanisms for TrustSec. So we've got the environment data download, where we download SGTs and the server list, and obviously downloading policy. But because we have a number of cases, because of the PAC timeout and the refresh and things like that, there was a demand to get rid of the PAC. And also for high availability reasons, if connectivity to ICE goes down, then obviously there's a problem, and customers wanted high availability. There is HA built into ICE, but let's say the whole communications goes down to every PSN. Then they want to switch over to a secondary cluster, ICE cluster. But you couldn't do that with the PAC, because the PAC is unique per cluster. So there couldn't be that sort of HA. So we've come up with Packless. It's in ICE 3.4. It's out now. And I support it in 17.15.1 in iOS XE. And it's backwards compatible. So if one or the other doesn't support it, then it will just go back to supporting the PAC. So hopefully that'll be useful to some of you that may have had problems with the PAC in the past. We already had a question about stateless and stateful. Of course, if you want stateful inspection, then use a firewall. Firewalls, stateful, uses SGTs, uses groups. You can simplify your policies on firewalls and have deep packet inspection, stateful inspection. Of course, we now have routers and switches. It's stateless. Or is it? Well, the answer is yes, but maybe we can get some use out of this configuration, permit TCP established. So what does this mean? It means it looks at TCP flags. And this established keyword actually looks at the RST and the ACK flags. So let's say you've got a server, and we're enforcing from the server to the client in this case, and we have this piece, permit TCP established. Well, in a normal communications, the client is requesting from the server, and get back from the server, we have this. This has got ACK, because we see RST. We've got the ACK and the FINAC. They've all got ACK or RST, so they're all accepted, no problem. It works fine. But what if the server gets compromised and starts sending SYNs out? Well, if it does, they get denied for policy because it doesn't have ACK or RST. So using the TCP flags can be quite useful, particularly in this case, gives you some sort of stateful inspection. Okay, not really stateful, but you know what I mean. So yeah, and there are other functions using other flags as well, so maybe you can look that up in the documentation. But if you're using TCP flags, you might think, well, I can't use Catalyst Center then, because that's a modeled configuration. You choose your applications in Catalyst Center rather than configuring things like adding keywords like established or adding port numbers. But there is, when you're adding a contract, you have this modeled option. Now, this isn't up here if you're necessary to read now, but you can read later. But if you deselect this modeled, i.e., I don't want to choose applications, I want to use text instead. So deselect that, and you can add text in the Catalyst Center. For example, this permit TCP established. So that's how you use these specialized functions that are supported on Identity Services Engine, but not natively in Catalyst Center. And this goes back to your question about syslog and monitoring. In 17.13, we came out with SGACL drops in NetFlow. So this is much more hardware-based as opposed to interrupting the CPU. And Cisco SNA, Secure Network Analytics, supports this in 7.4.2. And it's just a one-liner in our record. You see there, collect policy firewall event. And when we configure this on our interface, we need to put it on the output. As again, this came up before. It is an egress technology. TrustSec is egress on the platform. It's also egress enforcement from a network point of view. Because it's egress enforcement on the platform, then we add this to the output on our interface and on the monitor. So how does this work? Well, in Cisco Secure Network Analytics, we see this firewall event. In this case, it's permitted, and this one is denied. And you can actually look at it on the C line, look at the cache. In that case, you must look for a 1 being a permit and a 3 being a deny. So that's drops in NetFlow. Okay, so they're the 3 pillars. It's classifying things into groups, propagation, and enforcement. Let's move on to a great new innovation. I have this as a demo in the world of solutions. Look for security translation and common policy. So what is the need for this? Well, Cisco have a lot of fingers in a lot of pies. We take part in technologies in a lot of domains, which means we deal with them from a security point of view as well, of course. Software-defined access, whether it's Lisp or BGP, EVPN, non-fabric, SD-WAN, data center, so on, and also cloud workloads. So because of all these domains, how do we create a consistent security policy? Now, typically, we have admins in these domains, but how do admins in the data center know what's going on in other domains, and similarly in the other domains? So, how do they create consistent policies? That is the main challenge here. So what are we doing about this? Well, we've enhanced Identity Services Engine from ICE 3.4, and we've really improved our integration with APIC in the data center. So we've created a PX Grid client on APIC, so it can subscribe and publish the topics, PX Grid topics on ICE. So it's a proper context sharing technology between APIC and ICE now. Okay, and this technology is out now. It's in ICE 3.4 and also in APIC 6.1.1f, so it's out. But this feature, we said it's sort of limited at the moment, but it's going to be generally suitable in ICE 3.4 patch 1 and APIC, you see there, it's going to be generally available in 6.1.2. And this is like 2 weeks away, so it's very, very close. Proper context sharing, we can connect to multiple APICs, so multiple data centers, multiple tenants, multiple VRFs, multiple L3 outs. So it's much more suitable to our larger customers. And this is about normalizations I've got on the top right there. Sharing groups, so groups in the data center, EPGs and ESGs, endpoint groups and endpoint security groups, will learn into ICE. We'll normalize them into SGTs, but not just that, we'll learn the IP associations of those groups. The IP to SGTs will be created from IP to EPGs and IP to ESGs. We'll learn them as IP to SGTs in ICE. The other way is also true. We'll be sharing SGTs and the IP memberships to the data center. So you can build policies in the data center based off of group information you've learned from the campus. Okay, so that's one innovation. The next is cloud workloads. So you may spin up 100 new cloud workloads. How do you deal with that? Well, ICE now has a connection to these cloud providers, can learn the IP addresses, can learn the attributes, and we have a classification table to classify those into IP to SGT bindings, and share that now with the data center and ACI. We can share that with Catalyst Center. We're connected with a Catalyst Center, right? So if we learn or classify new groups, you can build policies in Catalyst Center because it learns the new group. We share this context with our network devices, routers, switches, firewalls. You can have policies on there based off of classifications you're coming from the cloud or even groups learned from the data center. We're sharing this with SD-WAN, okay? Build policies in there using these new groups, new learned groups. We're sharing this, I don't know if you're familiar with our SSE solution, our Cisco Secure Access. We're sharing SGTs and bindings with Cisco Secure Access. So you can build policies in there for traffic perhaps going to private public cloud. We're also sharing these groups with the Meraki dashboard. I talked about the policy sync there. Now we're sharing the groups and the configuration with Meraki dashboard. We're not quite sharing the IP to SGT bindings yet, but that's coming in a patch of 3.4. But it's about sharing this context in multiple domains so that admins there can create security policies based on the same information. That's what this is all about. So in the UI then, this is what you would configure. You have from ICE to APIC. You have a connect. There's a question? Yeah.
Maybe more like that.
Sure.
So this PX grid direct, which is from, let's say, VMware to the ICE, can ICE learn the tagging coming from the VMware, for example, vCenter?
Okay, so great question. So the question is about, can I learn the tagging coming from vCenter? And expanding on that, perhaps can we learn the tagging perhaps from AWS? Because they have security groups, right? It's not quite tagging, it's IP, but they have a group concept at least. And the answer is, well, through the classification table in ICE, we can use attributes from these services. So if, for example, AWS has a security group called PCI, then we can use that in a classification to say, is the security group PCI? If it is, then assign an SGT. For example, we could have a PCI SGT. So we can use them as attributes. It's not a one-to-one mapping of group to group, but we can use them as classification and use them to assign the appropriate SGTs. So I hope that answers the question.
Yeah. And then from ICE, on your slide, you have shown the integration from ICE to the APIC of ACI. But is this integration available to the NDFC as well?
Very good question. So is the integration, we talked about connection to APIC with ACI, is it also available with NDFC? Not today, but I'm having several meetings per week about how we design it with NDFC for NXOS support. So yes, it is coming, just not available today, but it's high on the agenda. Thank you very much. Okay. So we make a connection to APIC, but we set up this PX grid, proper context sharing technology. Group name normalization, we bring the group name back from ACI, back from the APIC. But what name do you want to call it? You may want to call it the same name. You may want to put a prefix or a suffix on it, because that's an option here. You may want to use some of the attributes from ACI, like the VRF or what have you, to rename that in ICE. So the admins in ICE can say, oh, this has come from ACI and it's come from that VRF or whatever. So it's the naming you can change. We also choose which groups we want to bring back. This is part of the initial connection workflow, configuring which groups you want to bring back into ICE. And in fact, what we're doing is we're telling APIC as to which PX grid topic for them to publish those groups into ICE. And then we choose what SGTs to use, numbers, because we have a range of numbers in ICE to use for SGTs, of security groups, and you may want to reserve a certain range just for the groups you learn from ACI. So let's have a demo then, connection from ICE to APIC. So in Identity Services Engine, under TrustSec, we have these integrations menu. This is brand new in ICE 3.4. And we have these connections, workload connections. So we don't have any connections at the moment. And before we do, let's have a look at the SGTs in ICE. Well, I'm going to add one starting with A. So we've just got auditors there, and then it goes on to BYOD, so you'll see that. New TrustSec matrix UI. Make note of that. This is coming in 3.4 patch 1. So if anybody's had a nightmare with the matrix, it's a new matrix. But you can use that group in ICE in the matrix. So let's add this connection. There's all sorts of connections we can have here. So let's click on ACI. I want to make a connection to APIC in this case. And of course, initially we put in the credentials. We want to connect to APIC to initially retrieve groups back into ICE. Of course, we put the credentials in here. We can use certificate normally in deployment. In the lab, I didn't use them here. So we'll go on in the workflow. And when we connect, I've got a cluster here, right? And it brings back all the APICs that's used for high availability. And then this is the naming. We can use attributes from ACI, the VRF perhaps, to say what naming convention I want to use in ICE. Now, we can also use a prefix or a suffix. And these attributes we bring back, we can change the name if we want. We can customize them. But in my case, we can use a prefix or a suffix. So I'm going to use a prefix in this example, just with ACI. So I'm going to put an ACI prefix in the front of these groups, learn into ICE, so that admins know where it's come from. This is where I choose the EPGs or ESGs to bring back into ICE. Just going to click these two. And then this is the numbering range. You don't have to create a numbering range. It will just use the next available. But in this case, I'm going to reserve SGTs 3,000 to 4,000 in this workflow. And then the workflow is finished with this summary. So if you're happy with the summary, then you just save the change. Now, you can jump to other workflows, but let's dismiss that for now. And then it's setting up this connection from ICE to APIC using pxGrid. So we'll refresh this a couple of times while it's negotiating. Remember, it's telling APIC as well to publish those two groups into ICE. So this is coming up. So let's go over to our SGT table in ICE. And you can see here, these two groups are in fact learnt by ICE. There are two new SGTs. It's using SGT number 3000 and 3001 within that range, and it has that prefix. And they're also in this matrix, the ICE TrustSec matrix. You see the two on the left, ACI Demo Client, ACI Demo Web. So you can immediately use these in your policy in the campus. This is based off of groups learnt from a different domain. So you see here. Now, what's really nice in APIC is this new menu called Integrations. And on the left is the ICE connectivity. So this is the one we just added. I can select on it, and we can look at the information. So this is the connection information. You can see here we're using pxGrid. And at the bottom, at the moment, APIC is just a publisher into ICE, publishing those groups and those IP memberships. It hasn't learned any SGTs yet. We haven't sent any in that direction. But it's sending these two and the memberships over to ICE. So that's making the connection ICE to APIC. Context sharing between domains. Now, there's a concept called domains within ICE. Now, really, these are spaces within ICE to keep these IP to SGT bindings. Now, the reason we have this is, let's say you bring back, say, some bindings from 3 VRFs from data center. You may not want to share all 3 with SD-WAN, with Cisco Secure Access, with network devices. So it's a way for us to segment these IP to SGT bindings in ICE, and these are called SGT domains in ICE. Before 3.4, they used to be called SXP domains. So if you're used to using this, we're just changing the name because it's being used for more things than just SXP. So they're called SGT domains. So they are just spaces in ICE to keep these mappings or bindings. So you have these different spaces. You have a default. So you don't have to mess around with domains if you don't want to. They all just go in the default, and you just share that everywhere if you want to. But you may want to add some other ones. Imaginatively, I've called them SGT A and B. But if you add a static binding in ICE, IP to SGT, you can put them in a particular domain. So in this case, we're putting them in the default. This entry we may want to put in 2 different domains, in domain A or B. And when we configure SXP connections from ICE, this is a speaker, so we're sending bindings out to a network device. We're saying I want to send bindings from domains A and the default. So it's just a way that we can segregate and send these bindings where we want to. Another example of ICE listening from a device, and we're putting them into default. And this is an SXP speaker on ICE, just sending the default out to another device. So it's just configurable how you want to do it. Now, the dynamic bindings, endpoints, users authenticating onto ICE, we're assigning an SGT. As long as the settings are set correctly, we put those dynamically assigned SGTs actually by default in the default domain, but you can use SXP filters to put them in whatever domain you want. And of course, we send bindings out through pxGrid. We share this context through pxGrid. But the reason I mention this is because this is important when on this integration and this new common policy integrations. We have these cloud classifications, and we have this connectivity to ACI. So we've come out with these filters called SGT domain, inbound rules, and outbound rules. So for inbound from the cloud, if we're classifying these workloads into groups, what domain do we put it in? i.e., where do we want to send them? Where are we configuring? We might not want to send them to all destinations. So we use inbound rules to put them into a domain so that we can filter it. And we also have an outbound rules from ACI, Because if you remember, I said up to now in the workflow, we've just brought groups from ACI into ICE. The outbound rules are to send ICE groups and context over to the data center in APIC. So that's what the outbound rules are for. So when we're configuring an inbound rule, we just give it a name. For its inbound, the destination is what SGT domain do we want to put bindings into. Here I've put employee. And then you just configure your conditions, whatever it might be, to retrieve, in this case, from my APIC connection, just from this tenant called demo, and either the EPG called demo WebEPG or client EPG. When I receive that information, I'll put that into that SGT domain. That's the inbound rule. We also have outbound rules. So in this case, we give it a name. From an outbound point of view, we're sending this outbound to APIC in the data center. Remember I said we support multiple VRFs. We support multiple L3 outs. So here, on the right-hand side there, we configure which L3 out do we want to send these groups to. And again, we configure conditions. What do we want to send? So we might want to send SGT domain employee, and what SGTs do we want to send? So this is how we configure what we send in this rule. But what is lovely at the bottom is that if we send this new group to APIC, what happens to data flow? Because we think, well, I'm then going to have to jump over to APIC, configure our contract so that traffic can flow. But what we've done is we've added the capability of connecting to an existing contract in APIC. So once we've chosen the L3 out and the SGT we want to send, we can go over and bring back the contract information and select it from the ICE UI, so that when we send the group over, traffic can immediately flow. So what does that mean so if we select this, what does it mean in APIC? Well, in the left-hand column here, we can go down to the external EPGs. Remember, when APIC learns of a new group, it's an external EPG. It's just the whole campus to begin with. It's very ungranular. If you want to build a contract in APIC, you just have to choose all the traffic coming from the campus to destination. You can't be any more granular than that. But once you've added a group over, like we did for employees, you see it come up as another external EPG. So this is the employees SGT4. In the release in 2 weeks' time, this will have the employee's name on this entry in this menu. But not only does it send that group, it attaches it to the existing contract if you've chosen that in the ICE UI. So here, it's connected as a new provider to the campus to web contract so that traffic immediately flows. So I thought that was a nice touch, that you don't have to then jump over to the APIC UI. Okay? So let's have a demo then. Sharing groups with ACI. This is the outbound rule. Again, Identity Services Engine, Work Centers, TrustSec menu. Now the rules are configured under SXP here. So we've got these inbound and outbound rules. So we're going to show the outbound rules. So we clicked on outbound. And let's create a new outbound rule. Notice there's none by default, so we don't send any groups to APIC to begin with. But we have this rule, so we give it a name, anything that's meaningful when you create these rules. And the destination is, well, I want to send it to this ACI connection, this APIC connection, and which L3 out. So I choose the L3 out I want to send it to. And then these are the conditions. So I might say, what SGT domain do I want to send, the bindings I want to send over? I'll say just the default bindings in the default domain. Now I can choose the SGTs I actually want APIC to subscribe to. So let's choose employees and finance. Let's send 2 over. And again, we can connect as a provider or a consumer of existing contracts. So jumping over to APIC, let's have a look to see what's available there right now. So we can go down through the menu, down to the L3 outs and external EPGs, which exist here before we submit this change in ICE. Whole campus, it's just everything coming in from the campus. Okay, that's how granular you can get with your policy right now. And let's have a look at the contract. So this is a graphic representation. We've got whole campus as a provider to the campus to web contract, and then we have a consumer. That's what we've got before we submit this change. And also, as I said, there's new integrations menu. You can select your ICE connection and have a look to see what's here before we make this change in ICE. Connection details, it's PXGrid. APIC is only a publisher right now, publishing information to ICE. It's not a subscriber yet, and there's no SGTs learnt in APIC just yet. So let's go back to ICE, and let's add one of these SGTs to use the existing contract. So we'll choose employees, and we'll say, yeah, let employees use that campus to web contract as a provider. And let's add this. So now we have this outbound rule. It's communicated with APIC. Successful. So what does that mean in APIC? So let's go to APIC, and again, we'll navigate down the left-hand menu. Go down through networking. This is through the demo tenant, because we support multiple tenants. Look at the external EPGs. Now we have these two new SGTs. 4 as employees. If we select it, look under operational, we can look at the SGT endpoints learnt. Here we have the group employees, SGT4, and the employee memberships, all the IP to SGTs of those groups, of that particular one group employee. We can also select 16. We know that's the finance group. As again, the name will be in the menu, but the name is here. We see the finance group, we see the number, we see the IP memberships of that group. In this case, I just have one in my lab. So the IP memberships. Looking at the contract, you can see now we have a new provider to the campus to web. The employees SGT4 has been added automatically to the contract. So that was the new function there. Integrations menu, of course, it's a great menu showing the summarization of what's been learned in terms of groups and memberships. You see at the bottom here, now APIC is a subscriber, subscribing to groups and learning them through PXGrid. And we can see all the endpoints here, the IP to SGTs in this menu. That was ACI. And of course, we talked about cloud workloads as well. And in fact, it's not just cloud workloads. We're connecting to the likes of VMware, vCenter, but it's a connector to external services, some being cloud providers. How does this work? Well, this is an AWS example. So in ICE, you can select AWS, and we can bring back attributes of workloads. What's important is learning the IP address, because we're going to map IP addresses to SGTs. But we'll learn attributes. It could be any of the attributes you've assigned in there. And we'll have a classification rule, using those attributes and assigning IP to SGTs, classifying the workloads into groups. You don't have to use all of these attributes in your policy. You select which ones you want to use, similarly to as we did with the PXGrid Direct example earlier. So we choose the ones we want to use in our policy. We have this classification table, classifying things into groups, and obviously assigning SGTs. Now, this is the first time I've mentioned secondary SGTs. We are now in the realm of assigning an endpoint or a user into more than one group at the same time. We've never, ever been able to do that before. Okay? Question?
So does that mean that we're putting 2 SGTs on the packet?
Okay, so the question is, are we putting 2 SGTs on the packet? We will be at some point, but so that was about, do we put SGTs in line in the CMD field? We're not doing that right now. We're sending it out via PXGrid, and I'm going to cover that shortly. So it's just been sent out PXGrid today. But even on top of that, we have no consumers of it yet either. But in the ideal world, and very soon, the firewall team, for example, could use that, and then you could build policies in there. What would be lovely is to say, is an endpoint or a user a member of Group A and Group B, really reducing the number of rules you may need. So that is really exciting for some customers. It's being made available in ICE. We're making it available, and hopefully consumers will come. thanks for the question. Primary and secondary SGTs. I'll do cover that a little bit more in a minute. Question?
Just related to the secondary SGTs, that is a plural, as in you can have multiple secondary SGTs.
Yeah, the question was whether you can have multiple secondary, and yes, you can. Yeah, it's been provided by ICE. We've got to have systems to make use of it. Yeah, thank you. So how do we add these classification rules? Remember, we're learning these attributes and the IPs, but we need to be able to put them into groups somehow. So you add a classification rule, you give it a name, and then you say, right, whenever I learn, I want to put it into this primary SGT, and you can optionally assign a secondary SGT. And then you configure your conditions, right? So you may have, as a condition, the source contains any of the labels. So these are attributes that you've learned from the cloud. So you can say, is this, as per that question about security groups, you could have a condition to say, is the learned security group, is it finance, for example? Other conditions, is the location London? You know, if all the conditions are correct, then you'll assign these SGTs. So any conditions. Now, what is actually quite nice is that we're classifying cloud workloads through the cloud connection. So what's the point of having a classification for the ACI connection coming in? Because we're already learning the EPG and the ESG, their groups are being learned, and we're assigning SGTs for them. But those groups, we're assigning the primary SGT. You can use a classification rule if you want to assign secondary SGTs to the ACI groups learned. So that's the reason why you can add it for ACI, to assign secondary SGTs in the plural. You can assign more than one. So yeah, the primary is the EPG, ESG learned, and you can optionally assign secondary. So to answer one of the questions as well, the primary SGT is what we've always known it as. Through PXGrid, it's just a session topic. It's known as the security group. And that's what we send out through SXP as well. The secondary SGT today is just being shared via PXGrid, and it's shared as an ordered array of multiples in what's called the secondary security groups, and we're hoping to have consumers of that shortly. So let's have a demo of classifying cloud workloads. So in Identity Services Engine, TrustSec menu, integrations. We've already added a connection to ACI. Let's add a new one. So under workload connections, let's add a connection. And through the workflow, now we'll select AWS as an example. So here we'll add the name, sync interval, and the AWS region. I've got an AWS web page open at the top. See, I'm using US East 1. So we'll put that in the region, and obviously you have to put in your API information, the key and the password. So you put them in. So we're just connected via API, and the whole point, we're not sending anything to AWS, we're just learning attributes, the IPs and attributes of workloads. And here are some of those attributes. So we've got security level. We could equally have security group. Application, location, name of the connection. Could be owner of the server, whatever you've got. And they're dynamic. You could add attributes. So this is actually AWS, and I've got 3 workloads in here. They're all finance type services. And one of the attributes, application, I've actually put finance in the name. So we could go to each one, and at the top we've got IP addresses of the workload. And under the tags here, we've got these attributes. So it might be location, state, name. What's important in our example is the application is finance pay that we've put in this attribute. So if we go back to our AWS instances, we can select on the second one, the tax services. Again, it's got the IP, and in the attributes, one that's important is application is finance-tax. And then we'll select the third AWS instance, PCI server, and under the tags, again, the attribute we're interested in is application finance-PCI. So how do we classify these workloads in ICE? Well, in here, this is where we choose what we want to use in our policy. So we'll choose a number of things. So we may want to use one or two now and some of them later. So we'll have owner, for example, just looking through the list. Could have location, location selected. Application, I want to use application because I want to make use of the fact that finance is in those names. And I'll have name as well. So let's choose them. They're the ones we're going to use in our policy either now or later. This is just a summary. So we'll create this connection to AWS. Successful. We have this connection, so it's up and connected. Now, we haven't received any SGT bindings yet because we haven't classified. We've made the connection, and we've brought down some attributes and selected which ones to use in policy, but we haven't classified yet. So this is where we add the classification rule. This is just showing the attributes again that we've selected. But we have this workload classification. This is where we add this classification rule. So we don't have one enabled by default, so we have to add one. So add a classification rule. As before, we give it a name which is meaningful to this rule. And this is where we would configure what SGT do we want to classify these servers into. So I'll select the finance primary SGT. And now I am going to set a secondary SGT. Let's set this to production servers so that we have assigned more than one SGT to endpoints at the same time. Now this is just our conditions. So I'll say source. Let's say it is from AWS. That's what I want to classify. And now I want to use an attribute I brought down. So AWS application, that's the attribute I want to use. And I'm going to say, does that contain the term finance? Remember, I had finance dash for all three of them. So this is how we're going to classify into those two SGTs, the primary and the secondary. So we save this. And refresh. And right, we see 6 bindings here, the 2 IPs per server. We learn and we are assigning them into groups. So under the workload connections, you can see here, we've learned these 6 bindings. And we can click on this to look at the IP to SGT bindings. And here, near the bottom, we have all these IPs. And if you remember any of the 54 or 172 IPs from AWS, these are the IP addresses learned, and using the classification, assigning them into the finance SGT, and the secondary SGT will be shown there too. Now we're sharing that information learned to devices like, this is an SD access border. So you can see the IP to SGT here has been classified and automatically shared down to other domains like the iOS XE device. We're also sharing that with data center. So if we look at the integrations in APIC here, click our ICE connection. And let's have a look at the endpoints. Again, IP to SGT for finance. Remember, finance is 16 here. We've learned the IP addresses, dynamically shared. Remember, we already shared the finance group. So the IP memberships are dynamically shared with those domains without changing your policy here. It's a dynamic technology. So you see the IP to SGTs there. Learned from the cloud, shared with the other domains. So, as a recap then, oh, right, there's a question, Peter.
So does that mean that the board is seeing the mapping, that it will impose the tag for transfer?
Okay, yeah, great question. Is how are we enforcing? So the question was if a network device receives these IP to SGT bindings, like I showed on the iOS XE device, the border, it's receiving the binding through SXP. What happens in terms of enforcement? Well, when the bindings hit a network device, like the border, for example, the border will say, assuming it's enforcing, the border will say, have I got a policy to enforce on this SGT? The binding it learns as an IP to SGT, have I got a policy? Go to ICE, have you got a policy for me to protect this SGT? And so it'll download it automatically from ICE, and so it will enforce because it'll download that policy automatically when it learns that mapping from SXP. Now that's assuming the border is enforcing, but it could be any device. Maybe it's an access device or distribution or core, in a typical layer 3 network. Again, we send the bindings from SXP. We learn them from the cloud. We learn bindings from data center. We'll send them down to a network device. As soon as it knows that it has that SGT to protect from SXP, it'll download a policy from ICE, only the policy that's needed to protect those SGTs. That's how we scale. So it'll have a policy. So it will enforce on the campus for traffic destined perhaps towards another domain, or traffic perhaps from that domain through to that device. So we will enforce based on information that we learn from other domains. Yes?
But if traffic is just transiting through it, it won't put the tag, the inline tag on the packet?
So the question is about, will it impose an SGT on traffic flowing through the box? Well, it will, so long as you're inline tagging from that box. Okay? If you're not inline tagging, then traffic will just go out as IP. There won't be any SGT associated with it. But if you're inline tagging onward and you send down an IP to SGT binding, traffic coming in, if it's just IP, it'll come into the box, it'll have a binding, it'll be reclassified, the source IP, and then when you forward it on inline tagging, the SGT will be imposed on that traffic outbound. Yes. But you have to say, I want to propagate it inline, so you have to configure the CTS manual and policy static commands to inline that onwards. Thanks for the question. Okay.
What is the definition here about? If you create a new resource in AWS with new tags, new formation, does this API have an internal policy in AWS?
Okay, great question, which was, is there an interval about how often we download information from AWS? And yes, there is a timer interval which can be set. I don't know if you remember or if you review the PDF, there is a timer setting when you make a connection to AWS. Remember, it's slightly different to ACI. With ACI and APIC, it's a proper PX grid sharing technology. It's PX grid to ACI. But with AWS, it's just API, so we're just going and retrieving information. And yes, there is a timer which you configure, which in my lab I set to 1 minute. I assume that wouldn't necessarily be you would want to do in the lab, in deployment. But yeah, we have a period for when we go to AWS to retrieve. And we want it fairly frequent, because you may be spinning up workloads all the time, right? You may be spinning up 1,000 workloads here or 500 there, and we'll be learning those IPs and classifying them depending on your rules. So yeah, good question, thank you. Another question.
With that, is there a refresh now button for if we're doing change control and changing an IP?
Good question. The question was, do we have a refresh now button to immediately get the update? There may be coming. If you remember in the PX Grid Direct demo I gave earlier, there is a refresh now, which we added in 3.4. I don't see it in the UI for the cloud connectivity yet, but we are just using PX Grid Direct. I don't know if you saw the similarities of selecting the attributes. So it is actually using PX Grid Direct. So I think it is coming, but I'm not sure what release. But yeah, it's a good question. Another one?
I know you covered it, but I don't remember. On the static assignment for default, and then we reclassify at the cloud end, so we get the mapping. I suspect it's the last mapping that takes precedence on the edge.
Okay. So the question is about precedence on the edge, because you could send multiple bindings down. And the answer is that SXP in general has two tables in a network device. It has what's called the SXP database, and it has the RBM, the role-based management database. Now, you could send multiple bindings down in SXP, and if you do a show CTS SGT map, no, show CTS SXP, look at the SXP table, you could see multiple entries. Because SXP takes account of multiple paths as well. So you can have multiple entries in the SXP table, but the RBM takes the best entry and puts it and uses it. So it takes the best entry. And normally in SXP, that's normally the shortest path. And if it's the same path, then it will take the latest one received. So it handles that itself in the network devices. And in terms of precedence, the same as routing, it'll be longest match too. So if you had like a subnet mapping, it'll use that. But then if you get more granular with /32, then it'll use that, take that as precedence instead. Did that answer the question?
Definitely.
Okay, thanks very much.
I think the granularity is also a big part.
Okay, thank you. Okay, so recap. Covered an introduction to the technology. We covered classification, propagation, and enforcement, and the new innovation, common policy. Remember, sort of a misleading term is not necessarily configuring policy in one place, because admins is a challenge to get that to work with the firewall teams and what have you. Because rightly so, we've got to think about security as a whole. But this project is more about the context, sharing the context so that admins have the same information, so building a consistent security policy. So, as I said, as a summary, this was about security agility using TrustSec and group-based policies. So before we wrap up, are there any more questions? One question at the back.
Do you have any resources in regards to the feature that you just spoke about, Meraki and the ICE in regards to the propagation of it?
Okay. There was a question about, have we got resources and information about ICE to Meraki policy sync? Yes, we do. That came out in a 3.2 patch 1, which was some time ago. So it'll be certainly in the official documentation. And also it's written up in the Identity Services Engine communities. If you look up cs.co/ICE-berg, you'll find all sorts of information in there about ICE and particularly the integration. Thanks very much. So the @ sign here is action for me. What action do I want you to take? Obviously go away if you haven't tried it. Try the technology. If you have, maybe try some of the new innovations, particularly common policy. And please complete your session evaluations. It's so important for me and you. I'd love 5s across the board. I may not get that, but if you mark a bit lower, then please let me know why and how I can improve in the future. But also, you get a t-shirt. I mean, no expense spared. Okay, so please complete your evaluations and your surveys. It's so important for me and you. And continue your education. Cisco stand in the world of solutions. I've set a stand up there. I've got colleagues showing the common policy integrations. We've got demos out there. You'll see they're fairly similar to the ones I've been showing today because it's pretty much the same. And book your one-on-one. I'm at the hub Wednesday for 2 hours from 11:30. So if you want to come and see me there and continue your education. Thanks very much.